Welcome back to the Real Number System. In this video, we're going to look at Module A, where we talk about clock and modular arithmetic. So here, you'll learn how to add and subtract on a clock. Let's get started. Because the numbers on the face of a clock don't go past 12, we need a special way to calculate time. For example, if you leave your house at 10 a.m., and you drive for 5 hours, at what time will you arrive at your destination? Well, I'm going to use the clock face to help me find the answer. So I start at 10, and I'm going to count around 5 hours on the clock face. So 11 would be the first hour, 12 would be the second hour. Now remember, when we cross 12, we're going from a.m. to p.m. 1 would be the third hour, 2 would be the fourth hour, and 3 would be the fifth hour. So we would arrive at our destination at 3 p.m. Again, remember, we started at 10 a.m. When we go across 12 noon, we move into p.m. This is not normal addition because our answer can never be bigger than 12. So it doesn't make sense for us to add and say 10 plus 5 equals 3. We need a new symbol then, to indicate that we're doing clock arithmetic. The symbol we will use is a plus sign with a circle around it. Arithmetic where numbers wrap around, as they do here, is called modular arithmetic. Since 12 is the largest number on the clock, we would call our clock arithmetic mod 12. And you can do modular addition with any number. For instance, if you had mod 5, it would be like having 5 numbers on a clock face. Let's look at another example. We're going to use our clock face to answer a question. And we're also going to practice writing our problem using our new symbol for clock arithmetic. So a doctor's prescription says to take a pill every 8 hours. We take our first pill at 7 a.m. So when will we take the next 2 pills? I would write this as 7. The plus with the circle around it means we're working with clock arithmetic. So 7 plus with the circle, 8 equals what? So I start at 7, and I'm going to count around 8 hours on the face of my clock. 1, 2, 3, 4, 5, 6, 7, 8. So that means I'm going to take my pill at 3. Now I started at a.m., I crossed noon, and so this would be 3 p.m. Now the problem asks, when do I take the next 2 pills? So the next pill is at 3. 3 plus 8, that would be 11 p.m. Suppose you're following a bean soup recipe that calls for letting the beans soak for 12 hours. We begin soaking the beans at 8 at night. So when should we take out the beans? I'm going to start by writing my problem. So I write 8, use your symbol for the clock arithmetic, and 12 equals what? I start at 8, and I'm going to count around 12 hours on the face of the clock. Now notice when I count around 12 hours, I end up back at 8. But I've crossed midnight, so this would be 8 a.m. now. So 12 is special when we add it. Adding 12 is the same as adding 0 hours. 8 plus 12 we just saw was 8. Well, 8 plus 0 is also 8. 12 is what we would call our additive identity in our clock arithmetic. The table below shows the sums for all numbers mod 12. Now we can use this table and think about our properties. Our commutative property holds. So a plus b on a clock is the same thing as b plus a on a clock. We also have an additive identity. Adding 12 to any number brings us right back to the same number. So 12 is called our additive identity. We also have inverses with a clock. Now typically an additive inverse is a number that I add to my number to make 0. But since 0 and 12 are the same on the clock, our additive inverse is the number that we add to make 12. Unlike integers, the additive inverse is not necessarily a number with the opposite sign. For example, 3 and 9 are additive inverses in clock arithmetic because 3 plus 9 on the clock equals 12. So let's find the additive inverses for each of the following. For part A, I want to know the additive inverse of 8. So 8 plus what makes 12? Well, 8 plus 4 makes 12, so 4 would be the additive inverse of 8. Part B, what is the additive inverse of 5? Well, 5 plus what makes 12? 5 plus 7, and so 7 is our additive inverse for 5. What is the additive inverse for 1? Well, 1 plus what makes 12? 1 plus 11 makes 12. And so 11 is our additive inverse for 1. Now, it's not necessary for us to count on the clock every time we're trying to add. When we're performing addition mod 12, we can simply add our numbers and divide the answer by 12. Our remainder is our answer. The quotient is not important here because the quotient just tells us how many times we go around the clock. So again, we don't really care about the quotient. We care about the remainder. The remainder will always be a number between 1 and 12 inclusive. Now remember, our 12 and our 0 are acting as the same. And so our answer to a mod 12 arithmetic problem will always be between 1 and 12 inclusive. Again, for clock arithmetic, 12 acts like 0. Let's look at some problems with clock addition. We're going to look at 2 different methods to add. So 6 plus 7 is 13. Now, in clock arithmetic, my number can't be bigger than 12. I'm going to divide 12 into my number. 12 goes into 13 one time, and I'm left with 1. I look at the remainder, and that's my answer. So 6 plus 7 on a clock is 1. For part B, we're adding 9 and 14 on the clock, so 9 plus 14 is 23. On a clock, my answer must be between 1 and 12. So let's divide 12 into our answer. 12 goes into 23 one time, and there are 11 left. I look at the remainder, and that's the answer to my problem. The 1 here, that's the quotient, tells me how many times I go around the clock, and the 11 tells me where I land. So 9 plus 14 on the clock is 11. Part C, 15 plus 58 on the clock. Well, 15 plus 58 is 73. Remember, my answer has to be between 1 and 12. So I divide 12 into my answer because I'm working in mod 12. 12 goes into 73 6 times, and I'm left with 1. Now the 6 tells me how many times I go around the clock. The 1 tells me where I land, and so the 1 is my answer. 15 plus 58 on the clock is 1. In part D, we have 3 plus 24 on the clock. Well, 3 plus 24 is 27. 12 goes into 27 2 times with 3 left. Again, the 2 tells me how many times I go around the clock, and the 3 tells me where I land on the clock, and so the 3 is my answer. 3 plus 24 on the clock equals 3. Now notice here, 24 is a multiple of 12, and when I added a multiple of 12, I ended up at the same number that I started with. Also notice that in my division, I was subtracting out a multiple of 12. This is going to help us with our second method for adding on a clock. So let's start looking at that second method. Now part A, we're going to work the same way because both of my numbers here are between 1 and 12. So 6 plus 7 is 13. Divide 12 into 13. We have a remainder of 1, and so our answer is 1. Now notice here, when I subtracted that 12 in my division, I subtracted a multiple of 12. 12 times 1 is 12. Let's look at part B. Part B is slightly different because notice that one of my numbers is bigger than 12. So what I do is I subtract out a multiple of 12 to figure out where I land on the clock. 14 minus 12 is 2. So what that tells me is 9 plus 14 on the clock is the same thing as 9 plus 2. And 9 plus 2 is 11. Let's look at another example. In part C, both of my numbers are bigger than 12. So I'm going to subtract out a multiple of 12 to figure out where I land on the clock. 15 minus 12 is 3. Now for 58, I need a multiple of 12 that's close to 58, but not bigger than 58. So 12 times 1 is 12. 12 times 2 is 24. 12 times 3 is 36. 12 times 4 is 48. We're getting closer. 12 times 5 is 60. That's too big. So I want to think about 12 times 4, which is 48. So 58 minus 48 is 10. Now notice again, I'm subtracting out a multiple of 12 to figure out where I land on the clock. So 15 plus 58 in clock arithmetic is the same thing as 3 plus 10, which gives me 13. Now this is bigger than 12, so I need to figure out where I land on the clock. So subtract out a multiple of 12, and 13 minus 12 is 1. Part D. We have 3 plus 24 on the clock. Well, again, 24 is bigger than 12, so I need to subtract out a multiple of 12 to figure out where I land on the clock. Well, 24 minus 24, 24 is a multiple of 12, it's 12 times 2. 24 minus 24 is 0. So 3 plus 24 on the clock is the same thing as 3 plus 0 on the clock, which is 3. If your problem contains negatives, you can just add with them. And you can turn the negatives into positives by adding a multiple of 12. On a 12-hour clock, 12 is our additive identity, so adding 12 or any multiple of 12 doesn't change our answer. Part A. Negative 4 plus 10. Well, that's 6, so I'm not going to do anything special for that one. But notice in part B, I have two negative numbers that I'm trying to add together. I'm going to change my negatives into positives, so I'm going to rewrite my problem. Now remember, adding 12 or a multiple of 12 doesn't change my problem. It tells me where I land on my clock. So negative 11 plus 12 is 1. So negative 11 is the same thing as 1 on the clock. For negative 19, I need to find a multiple of 12 that will give me a positive number. Well, 12 times 1 is 12. 12 times 2 is 24, so I'm going to add 24. Negative 19 plus 24 is 5. So negative 11 plus negative 19 on the clock is the same thing as 1 plus 5, which is 6. Let's look at another example. 5 plus negative 40. Again, I need a multiple of 12 that's just slightly bigger than negative 40. So 12 times 1 is 12. 12 times 2 is 24. 12 times 3 is 36. 12 times 4 is 48. So negative 40 plus 48 is 8. 5 plus negative 40 on the clock is the same thing then as 5 plus 8 on the clock, which is 13. My answer has to be between 1 and 12, so I subtract out 12 to figure out where I land on the clock, and I land at 1. For part D, there are two ways that I can work part D. I'm going to start with the parentheses. 20 plus 5 on the clock is 25. Now my answer has to be between 1 and 12. So I need to think about a multiple of 12 that I can add to negative 25 and get a positive number. 12 times 3 is 36, so I'm going to add 36, and that gives me 11 for my answer. Let's look at another method. Distribute the negative. So we'd have negative 20 plus negative 5 on the clock. Again, I want to have positive numbers, so I add multiples of 12 to figure out where I land on the clock. Well, negative 20 plus 24 is 4. Negative 5 plus 12 is 7. So negative 20 plus negative 5 is the same thing as 4 plus 7 on our clock, which is 11. Notice I get the same answer either way. Now, let's talk about subtracting on the clock. Subtracting means adding the opposite or adding the additive inverse. This is going to work here as well, but we always want to restate the numbers in the smallest convenient form to keep from having to divide 12 into large numbers. Also keep in mind that the remainder is what matters if we have to do the division. What that means is when I add or subtract a multiple of 12, I don't change my problem. And I want to add or subtract multiples of 12 until I get to a number between 1 and 12. Our answer in Mod 12 arithmetic or in clock arithmetic will always be between 1 and 12. So let's look at an example. Here we have in part A, 3 minus 11 on the clock. Well, I can change my subtraction to addition. I think about the additive inverse of 11. Remember, the additive inverse is the number that we add to 11 to get 12. Well, 1 would be the additive inverse because 11 plus 1 is 12. So here we have 3 plus 1 on the clock, which is 4. In part B, both of my numbers are bigger than 12. So I'm going to subtract out multiples of 12, just like we did with your addition, to be sure I start with a number between 1 and 12. So 17 minus 12 is 5, and 33 minus 24 is 9. Again, I use multiples of 12. So 17 minus 33 on the clock is the same thing as 5 minus 9. I can change the minus to a plus and add the additive inverse. The additive inverse of 9 is the number that I add to 9 to get 12. Well, 9 plus 3 makes 12. And 5 plus 3 on the clock is 8. Let's look at another example. Here we have negative 15 minus negative 8. To get rid of the negative numbers, I'm going to add multiples of 12 to see where I would land on the clock. Negative 15 plus 24 is 9. 24 is 12 times 2. Negative 8 plus 12 is 4. So here, negative 15 minus negative 8 on the clock is the same thing as 9 minus 4 on the clock, which is 5. Look at part D. Here we have negative 46 minus negative 29. Again, the first thing I want to do is change these negative numbers to positives by adding multiples of 12 to see where I land on the clock. Negative 46 plus 48 is 2. 48 is a multiple of 12. It's 12 times 4. Negative 29 plus 36 is 7. 36 is a multiple of 12. It's 12 times 3. So in this problem, negative 46 minus negative 29 on the clock is 2 minus 7 on the clock. Subtracting is the same as adding the additive inverse. The additive inverse of 7 is the number that I add to 7 to make 12. That would be 5. And 2 plus 5 on the clock is 7.